In this video, I'm going to cover how to answer questions from the Unit 9 review. I would suggest as soon as you receive your test to write the following information at the top of your exam. This will not be provided to you. Now, what does this mean, all-star trig class? It means all trig functions are positive in quadrant 1. Sine and its reciprocal cosine are positive in quadrant 2. Only tangent and its reciprocal cotangent are positive in quadrant 3. And cosine and its reciprocal secant are positive in quadrant 4. Okay, remember that trig functions are just a ratio. Trig functions are a ratio of two sides of a right triangle. And so how do we choose the two sides? Well, we have a way that we can remember this. Oscar had a heap of apples. If we write them in this order, Oscar had a heap of apples. And this tells you what two sides and the order to select the two sides in a right triangle. So for sine, I'm going to put in the numerator the opposite side of the angle that has been chosen, and hypotenuse will be in the denominator. Hypotenuse will continue to be in the denominator for cosine, and we'll choose the adjacent side of the given angle. For tangent, it'll be opposite over adjacent. These are two special triangles from geometry that you do need to memorize and apply. Let's get started on number 1. I'm going to choose to look at 24. I can divide it by 3 and receive a nice whole number of 8. That tells me I can count in equal numbers of 30 degrees. In each quadrant, there are 3 equal sectors or slices of pizza in each one of these quadrants. So there's 3 equal sectors in each, and the interior angles of each of those sectors is 30. So I can count and go 30, 60, 90. I want to do 8 of these. So 1, 2, 3, 4, 5, 6, 7, 8. This is where 240 degrees lies. Now I need to create this into a triangle. We are always going back up to the x-axis. And I'm going to draw this triangle off to the side. The interior angle that's created using the x-axis will always be my reference angle. In this case, this interior angle is 60 degrees. So now I know that if this is a right triangle, this is 60 degrees, this has to be 30. I'm going to reference my 30, 60, 90 triangle along with the ratios that correspond to each side. So opposite of 60 degrees would be radical 3, opposite of 30 is 1, and opposite of 90 is 2. Let's now convert 60 degrees, we're now going to convert this into radians. So what is 240 degrees? 240 degrees converted into radians. Well, when I'm counting by 30-degree increments, it's the same thing as counting as 1 pi over 6. 1 over 6, 2, 6, 3 over 6, 4, 6, 5 over 6, 6, 6, 7 over 6, 8 over 6. 8 pi over 6, and that reduces to 2 or 4 pi over 3. Some of you have chosen to memorize these. The one mistake I often see students making is forgetting to apply the correct signs. So let's start with sine. From this angle, sine means opposite over hypotenuse. Opposite is radical 3. Hypotenuse is 2. Let's go down and be careful. This says cotangent. That means I want to figure out what is the tangent, and I want to take the reciprocal of it. So let's identify the tangent first. Tangent is opposite over adjacent, but again, I want to flip them, so I want to do adjacent over opposite. Okay, from this angle, the adjacent side is the side that helps create this angle, but it can never be the hypotenuse. So 1 is on top, and the opposite is radical 3. Now, this is not mathematically wrong, but it's not in proper form, so I do need to rewrite it. Multiply by radical 3, and I get radical 3 over 3. Before I'm done, I need to go back and look. In quadrant 3, only tangent and its reciprocal are positive. Everything else is negative. Let's take a look at number 2. 3 pi over 4. When 4 is on the bottom, I can count by 45s. 1, 2, 3. This is the angle 3 pi over 4. Again, we're going to create a right triangle with the x-axis. I'm going to come off the side and create that. That interior angle is the angle that's referred to as the reference angle, and that's a 45-degree angle back to the x-axis. This is 45 and 90. Now I need to refer back to the information I wrote at the top of the paper. You will need to memorize that. Now let's convert 3 pi over 4 let's convert this into degrees. So I want 3 groups of 45. So I'm going to take 45 and take it times 3 to end up with 135 degrees. Also, by the way, it's possible they want you to write this in terms of radian measurement. I would accept either if it doesn't say specifically what it has to be. I always think of reference angles in terms of degrees. What I'm sharing with you is if you write pi over 4, I would not count it wrong. You do not have to write both. Okay, this is the reference angle here. And now I want to identify the cosine. Cosine is adjacent over hypotenuse. Okay, so adjacent is the side that helps create the angle, and hypotenuse is going to be radical 2. This is not wrong, but it's not in proper form. Multiply it times radical 2, and I end up with 1 times radical 2 over 2. I'll come back to the sign of it later. Cosecant. Cosecant is going to be the reciprocal of sine. So I want hypotenuse over opposite. What is the hypotenuse? The hypotenuse is radical 2. What is the opposite side? It is 1. So radical 2 over 1, or simply radical 2. Now this landed in quadrant 2. Only sine and its reciprocal are positive. So it's a positive radical 2, but it is a negative radical 2 over 2. Let's take a look at number 3. Number 3 is negative 30. Whatever it's negative, I've got to drop it down. So I'm dropping this down and then creating that angle. I'm going to draw the triangle off to the side. This interior angle here is going to be at this 30-degree reference. Then your reference angle is always going to be, again, your reference angle is always the distance back to the x-axis. Remember, distance is always positive, so our reference angles here will always be positive. So if this is 30, this is 60. My reference angle is always closest to the origin. Across from 30 is 1, across from 60 is radical 3, and the hypotenuse is 2. The reference angle is 30 degrees. And now if we want to convert negative 30 degrees into radians, so 30 degrees is the same as 1 pi over 6, but we did a negative 30, so negative 1 pi over 6, which is the same, by the way, as negative pi over 6, if that's how you choose to write it. Tangent is opposite over adjacent. Okay, so this is my angle right here. Opposite is 1, and adjacent is radical 3. Again, this is not wrong. I selected the correct numbers, but it's not written correctly. It's not in proper form. So radical 3 over 3, I'll come back to the sign later. Secant is the reciprocal of cosine. So the reciprocal would be h over a. H over a. Okay, your hypotenuse is going to be 2. Your adjacent side is going to be radical 3. And again, this ratio I created is correct. It's just not in proper form. Radical 3 is 2 radical 3 over 3. Let's go back and look. This landed in quadrant 4. In quadrant 4, only cosine is positive. So tangent is negative, but secant is the reciprocal of cosine. It remains positive. Looking at number 4. So it's going by 3s. I want to turn this into a 6. So I have negative 16 pi over 6. Negative 16 pi over 6. So I'm going to count backwards in increments of 30 degrees. Here we go. And I want to do 16 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Remember, there's 12 positions when we're counting in terms of pi over 6. So I've done 12, 13, 14, 15, 16. This is the reference angle. I'm going to draw this back over to the side. This is 60 degrees back to the x-axis. Opposite of 60 is radical 3, opposite of 30 is 1, and the hypotenuse is 2. Now let's convert this into degrees. So there's a couple different ways we could do this. Myself, we did one revolution, and it was backwards, by the way. So I'm going to come over here and write, so negative 360 one time, and then we did additional 30, 30, 30, and 30. So 4 groups of 30 is 120. So I wanted to add together 360 plus 120, and that would provide us a negative 480. A negative 480. Okay, so this is our angle. Sometimes students get mixed up. What is a reference angle? Sine is going to be opposite over hypotenuse. Okay, so opposite of this is radical 3. Hypotenuse is 2. I'll come back to the sine later. The cosecant. Okay, the cosecant is going to be reciprocal of sine. So instead of opposite over hypotenuse, it's hypotenuse over opposite. The hypotenuse is 2, and the opposite of this angle is radical 3. Those are the correct sides, the correct ratio for the provided trig function, but it's not in proper form. So I have 2 radical 3 over 3, and now I'm going to take care of the sines. This lands in quadrant 3. In quadrant 3, only the tangent is positive. Neither one of these are referring to tangents, so it's both going to be negative. Let's look at number 5. Number 5 is not one of the common angles. So I'm going to grab my calculator, and I'm going to take just a normal 483, and I'm going to subtract 360. So I want to do one revolution. I know it's going to be backwards, plus an additional 123 degrees. So let's just do one revolution backwards. Got it. Now 123. If I subtract 90, that would be an additional quadrant. I'm left with 33. So I know 30 is here, just a little bit more here. So this is where it lands. It does land in quadrant number 3, but now the reference angle here, the reference angle is not one of our common ones. So if this is 33 degrees, and we know that this quadrant, in fact, all quadrants have to add up individually to 90. I've gone 33 additional. Well, if I take 90 subtract 33, 90 subtract 33, I can see I have a reference angle of 57. Okay, so in a triangle, we know all of the angles add up to 180. Well, I already have a 90. That means these two angles have to also add up to 90. So 90 subtract 57 gives us that 33. This is the reference angle. It is the one closest to the origin, and it's created using the x-axis. So my reference angle here is 57 degrees. Now, we need to create this back into radians. And by the way here, when I'm looking at this, I bet you, I did remember to put a negative sign because it went backwards. Right away, I know this is going to be negative at the end. So how do we come up with this? So we need to put this, it was in degrees, we need to go back into radians. So how do we convert when it's not one of the common ones that we can do with mental math? I'm going to multiply by pi over 180. I'm going to grab the calculator. Don't worry about the negative sign right now, and do 483 divided by 180. Hitting math fraction, enter, enter. And here we go. We have an answer of negative 161 over 60. And don't forget about the pi. Let me let the dog outside 1 second. Apologies there, and letting the dog outside quickly. So we can see 161 over 60. Don't forget to include this pi symbol. So I've converted this and the negative sign as well. Now I have my angle, and I need to find the secant. We're going to end up rounding this, and you will have a problem like this on your exam. So secant, I know secant is reciprocal of cosine, so let's first figure out what is the cosine of this. So I want the cosine of this angle. Now this is in terms of degrees, so let's hit mode and make sure that we are in degrees. All right, so cosine. What is the cosine of 57? But I want to take 1 over that because it's the reciprocal of this. Now, I don't want you to type in 0.5 or 0.54. I want you to actually where you hit the second key and hit answer, which is below the 3. So we have the exact previous answer. And now I can type in 1.83. I'm going to go 4 places after. I'll come back and figure out is it positive or later after I do the next trig function. Cotangent is the reciprocal of tangent. So again, let's figure out the tangent of this angle. Tangent of 57, and then 1 divided by it because we're looking for the reciprocal of tangent, 0.6494. All right, my next objective will be to come back here and go in quadrant number 3. Only the tangents and its reciprocal are positive. Everything else is negative. Let's take a look now at number 6, moving this up. For number 6, it's one of those common ones. Let's count by 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. And by the way, I'm counting by 6 over 1. So like 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5, 6, 6 over 6. 7 over 6, 8 over 6, 9 over 6, 10 over 6. Here's 11 over 6. And for those who are pretty knowledgeable now about the unit circle, you probably just dropped down 1 or maybe even had this memorized. Okay, now here's the key here. My reference angle is the angle created. It's the angle created here with the x-axis. So I'm going to come back here. It's this angle right here, which is 30 degrees, which you could reference as pi over 6 if that's what you prefer. I'm going to write 30 degrees. And then here is my right angle, and this would be 60 degrees. Opposite of 60 is pi over 3, 1, and 2. This is the reference angle. Let's convert this into degrees. Well, I know that we have 30 degrees to get back to this horizontal axis. So 360 subtract 30 is going to be 330 degrees. I converted radians into degrees. Okay, so this is my reference angle. Tangent is going to be opposite over adjacent. The dog's back. Give me 1 second. Come on, Peter. All right, so opposite of this reference angle, opposite of this angle is going to be the value 1, and adjacent is going to be radical 3. That's the correct ratio, but it's not in proper form. Radical 3 is radical 3 over 3. I'll come back and identify the proper sign in a little bit. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent means it's the side that's creating the angle, but it can't be the hypotenuse. So radical 3 over hypotenuse, which is 2. Okay, this lands in quadrant 4, and in quadrant 4, only the cosines are positive. So positive and negative. 495 is more than 1 revolution. 1 revolution is 360 degrees. So I'm going to take 495 and I'm going to subtract 360 to end up with 135. Okay, so 1 revolution, and then it's going to land right here at this 45 degree mark. This is a 45 degree reference angle, so I'm going to come off to the side and draw this 45, 45, and 90, which is 1, 1, and radical 2. The reference angle is 45 degrees. When I convert this, I want 1 revolution. We're going to convert into radians. So 1 revolution, which would be 12 pi over 6, or 2 pi. But you know what? I think I can do it better by writing it with 4 on the bottom. 1 revolution is going to be 8 pi over 4. How did I get that? 1 over 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4, 7, 4, 8, 4. So 8 pi over 4. Plus, I want to count 1, 2, 3. 3 pi over 4. That leaves us with 11 pi over 4. Now you also could have taken this and taken it times pi over 180. So I'll grab the calculator and demonstrate. 495 divided by 180. Hitting math fraction, enter, enter. We get the same thing, 11 over 4. Don't forget to put a pi there. Sine is going to be opposite over hypotenuse. So opposite is 1, hypotenuse is radical 2. All right, let's put this into proper form, and we end up with radical 2 over 2. I'll come back to the sign later. Cosine is going to be adjacent over hypotenuse. So 1 over radical 2, I don't need to do the math. I can see it's the same value. We just need to go back and figure out which one is positive or negative. Maybe they're even the same sign. So in quadrant 2, only the sign is positive. Sign is positive, that makes our second value negative. Negative 5 pi over 6. So I'm going to go backwards, counting by 1 pi over 6. 1 over 6, 2, 6, 3, 6, 4, 6, 5, 6. Creating the 90 degrees with the horizontal axis. This is my reference angle. So I'm going to draw that off to the side. This is 30 degrees and 60 degrees. Opposite of 30 is 1. Opposite of 60 is radical 3. Let's convert this into, so if this was negative, I know this has to be negative. So there's a couple different ways we can do this, and I'll demonstrate both. Myself, I count by 30. So 30, 60, 90, 120. Okay, that's negative 150 backwards. Well, what's another way you can do it? You can take it times 180 over pi. The pi's are going to simplify to 1, so an alternative way would be negative 5 times 180 divided by 6. We get the exact same answer. All right, so this is the reference angle. I did see quite a few kids getting confused on which angle they were referencing when identifying the two sides. So tangent is opposite over adjacent. I want opposite over adjacent. So from this angle, opposite is 1, adjacent is radical 3. 1 over radical 3, let's put it into proper form. Radical 3 over 3. I'll come back to the sign. Well, cotangent is just the reciprocal of tangent. So I'm going to go back to before I put it in proper form, and it's going to be radical 3 over 1, or simply radical 3. In quadrant number 3, tangent and its reciprocal are positive. Let's look at 135. I know by memory this is where 135 is. It's a 45-degree measurement in quadrant number 2. This is the 45-degree measurement, that interior angle, and this is also 45. So this is 1, 1, and radical 2. Let's convert this. Reference angle is 45 degrees, or pi over 4, however you want to express it. Let's convert it into radians. 1 over 4, 2, 4, 3 over 4. 3 pi over 4. The sign is opposite over hypotenuse. Opposite over hypotenuse. I selected the correct ratio, but it's not in proper form. Radical 2 over 2, I'll do the signs later. Tangent is opposite over adjacent. So opposite is 1, adjacent is 1. 1 over 1 is simply 1. Now this lands in quadrant 2, only the sign and its reciprocal are positive. Let's look at the last one here. All right, so a lot of students get confused here, and they're wondering, is this degrees? It is not. We would see a degree symbol here. So it's negative. I know I'm going backwards. Let's just take a look here. If I did pi divided by 2, it'd be right here, this measurement, this would be a negative 1.5 approximately. We know pi is approximately negative 3. Let's do 3 pi over 2. So 3 pi divided by 2, that'd be negative 4.7. And 2 pi all the way around, it would be a negative 6.28. So I want negative 5.2, negative 5.2. All right, so that's looking, well, let's just see what's in between these, by the way. So 4.7 plus 6.28, if I add them up and divide by 2, right here, right in the between here, this would be negative 5.4, and I want negative 5.2. So right about here, this would be negative 5.2. Let me draw the triangle. Okay, so now I'm going to convert negative 5.2 into degrees. So to do this, I know this is in radians, so radian has to go on the bottom, and 180 is on top. Let's forget right now about it being negative. Let's just take 5.2 times 180 and then divide it by pi. So this is equivalent to negative 297.938. Okay, So how does that help me? Because I know 1 revolution is 360, and when I create this triangle, this has this additional measurement added to this has to add up to 360. So I'm going to take 360, I'm going to take 360 and subtract this exact number, so second answer, and this tells me my reference angle, 62.0619. That is my reference angle. Now, I did it in terms of degrees, and so if we look on the answer sheet, they get it in terms of radians. So let's put it in terms of radians. I'd be completely fine with this. If we want to convert this to radians, by the way, we're going to multiply by pi over 180. So take this times pi and divide by 180. And if you had an answer key, the answer key, or if you had a picture of it, it said 1.8. That's in terms of radians. In my mind, I just like working with degrees often when I do these reference angles. So this is 62.0619. That is my reference angle right there. Okay, so when I go and I find the secant of this, I'm going to find the cosine. Let's first make sure we're in degrees, since I'm going to choose to use the degree measurement. If you choose to use the 1.08, make sure you remain in radians. Okay, so I know this is reciprocal of cosine. So cosine of 62.0619. And now I need to do 1 divided by that exact answer. So I have 2.1343. Okay, I'll worry about positives and negatives later on. Let's do the cosine. So cosine of this, what we just did that, is 62.0619. And we end up with 0.4685. Now this lands in quadrant 1, and in quadrant 1, all things are positive. So if you took a picture last week of the answer key to the review provided by Mr. McFarland, I wanted to let you know you do not have a problem like this. You do not have a problem like this on your upcoming exam. You do not have a problem like 5 pi as well. Let's get started on part 2 of the Unit 9 review. Let's start by reviewing the 6 trig functions before we attempt to do 11, 12, 13, and 14. This also may be something that I write on my paper if I were you. So let's just talk about the sine. So when we think about the ordered pairs, sine is like your y value. So sine and cosine have a phase, oh, that marker does not work well on this. Let's choose a different one. Sine and cosine have a phase length. That marker doesn't work well, so we'll throw that one away. Let's try this again. There we go. Okay. So sine and cosine, along with the reciprocals, have a phase length of 2 pi, so that when we are graphing, think of this as going 1 time around. Sine is like the y's. So right here, I have a y value of 0. I have a y value of 1, 0, -1, and 0. So when we think about graphing it, that's our output values. So when I graph, I go 0, my step 1 goes up to 1, step 2 is back to 0, step 3 is at -1, and step 4 is back to 0. 1, 2, 3, 4. Those are my 4 steps for a sine function. It is a length of 2 pi. I'm going to erase this, and then let's look at cosine. Cosine and its reciprocal, like sine and its reciprocal, have a period length of, of 2 pi. So cosine provides an output value like x. So here, our x is going to be 1 because it's 1 to the right, 0, 1 to the left, and 0. So when I create a cosine function, my output is 1. Now step 1 is 0, step 2 is -1, step 3 is 0, and step 4 is back to 1. So this demonstrates what one cycle of a cosine function looks like. So let's now look at tangent. Now, tangent and its reciprocal is different than sine and cosine. With tangent, we only have a phase length of pi. So I'm still going to do 4 steps, but it could only be on the top half. Oh, I'm going to sneeze, I'm sorry. about that. It can only be in the top half. And so how do we figure out tangent? Well, tangent is actually sine divided by cosine. So I'm going to look back here, and I'm going to first write down all of the signs. So I'm going to write down the sign here and here and here. That's my first part. So 0 divided by something, 1 and 0. 1 divided by and 0 divided by. Now I got those because I know tangent is sine, and now I'm going to divide it by the cosines. So 1, 0, negative 1. 1, 0, negative 1. And we still have 4 steps. So here I only have 2 steps, 1, 2. So we're going to have, and they're equal, so I need to have these as well. So this is the 45 degrees, and this is a sine of radical 2 over 2 divided by radical 2 over 2. Here it's radical 2 over 2 divided by negative radical 2 over 2. Okay, so now let's figure out what are the outputs. So here it's easy to figure out the outputs. The outputs are already there. Very easy to graph. Outputs are already there. Very easy. I'm going to redraw this half circle so it's easy to see the outputs. 0 divided by 1. Now this is for tangent. 0 divided by 1 is 0. When you have the exact same number divided by itself, it's 1. 1 divided by 0 is undefined. Radical 2 over 2 divided by a negative radical 2 over 2 isn't a value of 1, it's negative 1. And 0 divided by negative 1 is 0. So here's your steps. Step 1, 2, 3, and 4. So let me graph that now. Okay, so we're starting here at a step here of 0. Now step 1 is going to be at 1. Step 2 is going to be undefined. Make sure to draw those dotted lines representing a vertical asymptote. Step 3 is going to be at negative 1. Step 4 is back to 0. And then we'd continue. It'd go to 1. And then it'd be undefined, and you just continue to go. Just like over here, if I go backwards here, we'd have negative 1. And then it'd be undefined. And that's how we get tangent. So the exact same thing. This would be a negative 1 over here. For our next step after this would be a negative 1, 0, and 1. And then it'd be another vertical asymptote. I'm sorry, I couldn't see that. You weren't able to see that. 0, 1, undefined. Negative 1, 0, and then we cycle back again. Here's your 0, 1, undefined. Negative 1, 0, 1, undefined. Okay, now let's look at the reciprocals, because we do have to know how to graph all 3 of the reciprocals for the test. If you, oops, sorry there. If you understand, without the glare, if you understand how to graph the most basic sine function, then graphing its reciprocal is not too hard. So what I'm going to do is I'm going to create another graph down below. And I'm going to come up above, and I'm just simply going to write the reciprocal of the output values. We still have a length of 2 pi for the cosecant, which is going to be the reciprocal. So y equals cosecant. Now the way I remember is I remember that s can't go with another s. So sometimes students want to put sine with secant, both with s's. The same start, so the first letter of this trig function, s, can't go with another s, so s and c go together. So I'm going to write, to find the reciprocal of this, I'm going to put 1 over it. So 1 over 0, 1 over 1, 1 over 0, 1 over negative 1. Okay, now we can begin graphing. I was hoping to find a marker that was a different color to represent the vertical asymptotes. It may not be very pretty, but I think this will work. Okay, so I'm starting here, the exact same spot that I started for sine, and I know we can never have 0 on the bottom, so I'm starting off at already having a vertical asymptote. Now my first step was going to produce a 1, so I'm going to go over 1 and up 1. My second step is going to produce another vertical asymptote. My third step is going to produce a -1. And then it just keeps cycling around. So this would be, there we go, just keeps going. Now remember, these you can't cross over. So these are going to go up and down and up. So there'd be another one here would be down, and then we'd have another asymptote, and then it would be up, and so on. So this is going to be our cosecant, CSC. Let's look at secant. Okay, let's do the exact same thing for cosine. So I'm going to make myself a circle. Remember that cosine and sine and its reciprocals all are going to have a period length of 2 pi. So I'm going to write 1 over the output values for cosine. So 1 over 1, 1 over 0, 1 over -1, and 1 over 0. So 1 over whatever previously was the output values for cosine. So I'm starting here at an output value of 1. My first step, I can't have 0 on the bottom, is undefined. Then I have an output value of -1. Then I have an output value of, can't have 0 on the bottom. Then I have output value of 1. Then I have an output value, and it just keeps going. And it just keeps going as you cycle around. And each of these is going to go opposite direction for the basic parent function. It's going to go the opposite direction of the horizontal axis. So this is y equals, so the reciprocal of cosine is secant. This is the basic parent function. Now let's look at cotangent. Okay, so in about 3 or 4 minutes ago, I went over tangent, and so 0 over 1 produces a 0. The exact same values divided gives us 1, 1 over 0, undefined, and you can see the rest. Now, what if we flip those? So this is what we had. What if we flip those? Because cotangent is going to be the reciprocal. So if I take 0 over 1 and I flip it, I'd have 1 over 0. Can't have that. It's undefined to start. Remember that cotangent and tangent only have a phase of pi. That's why you're only seeing half of a circle. At 45 degrees, even if we switch it, we still have radical 2 over 2 divided by radical 2 over 2. That's still going to be a value of 1. Now we had 1 over 0 because it's sine over cosine, but now when we flip it, taking the reciprocal, I get a value of 0. Here, the exact same thing when I flip it, and so instead of being sine over cosine, it's cosine over sine. I still end up with a value of -1. And now at this point of pi, I had 0 over -1. When I flip it, I have -1 over 0, which is undefined. So that's going to help me in graphing this. Let's still have 4 steps, and the 4 steps is start 1, 2, 3, 4. So I'm starting at undefined, so this would be dotted. If I could just take off some here, this would be dotted. All right, and now step 1 is going to give us a value of 1. Step 2 is going to be 0. Step 3 is going to be -1, and step 4 is undefined again. But there's one cycle, and we can do it again. So we're at undefined, and then we go 1, 0, -1, and undefined again. And it just continues to go to the left and to the right. All right, now let's jump back, after reviewing that, to part 2 of the Unit 9. Let's take a look now. Remember, you will not be able to use a graphing calculator when you are graphing 11, 12, 13, 14. You will have a unit circle and a blank piece of paper to write on, but you will not get to use a graphing calculator. So, cosine. I'm going to take a look at what our cosine is, and we're going to zoom out here. So this was our basic cosine function with each of our steps being, here we go, 1, 0, -1, and 0. All right, let's take a few predictions. This tells me that we're going to reflect across this horizontal axis. This is different than the negative sign. The 2 tells me it's going to be stretched vertically by a factor of 2. And 2 over 3 says it's going to change the length of both the x scale and of the period length. Now I'm going to start with the period length. I'm going to take 2 pi and I'm going to divide it by the value in front of the x, which is 2/3. Because it's a fraction, I could write divided by 2/3, but I know a shortcut when you have fractions that you're dividing by is to multiply by the reciprocal, which is 3 over 2 in this case. I end up with 6 over 2, and 6 over 2 is going to reduce to 3 pi. So I'll write down 3 pi, and 3 pi will represent what this period length is. Now, there's still going to be 4 steps, and so when I divide this by 4, I get 3 pi over 4. So each step along the horizontal axis is a distance of 3 pi over 4. Make sure you're connecting your dots so I can see this. So myself, I'm thinking I know that a normal cosine is 1, 0, negative 1, 0. I'm even going to write that down. 1, 0, negative 1, 0, back to 1. So this is step 1, 2, 3, and 4. So I'm starting at 1, but I have to multiply it by a negative 2. Negative 2 times 1 is negative 2. Negative 2 times 0 is 0. Negative 2 times negative 1 is a positive 2. Negative 2 times 0 is 0. And negative 2 times 1 is negative 2. This is one cycle. Now they do want us to graph the entire length here. So I'm going to go back up and keep going. Please do not just leave the dots here. Please do not just leave dots and not connect them. Now on your test, you do not have to write how many we go to the right and how many we go to the left like we did at homework. This is completed for number 11. Let's take a look now and let's go straight over to number 12. What's a quick way that I could do this by not referencing what I already created? So this is what I've already created. Remember, I reviewed this with you, but what's a quick way for me to do that? Well, the first thing I'm going to do is I'm going to fill out these two. Remember that cotangent, tangent, the reciprocals of each other, only have a period length of pi. So I'm going to take pi and divide it by the value in front of the x, which would give me a period length for this function of pi over 3. We still have 4 steps, so I want to divide this by 4. I want to take pi over 3 and divide it by 4, which is the same as multiplying by the reciprocal of 1/4. We end up with 1 pi over 12, or just pi over 12. So how do I go about this? I've already taken care of 3. How would I go about doing this? Well, myself is I would make a half circle, knowing that tangent and cotangent only have a period length of pi, and then I would mark off each one of these points. And I personally would go, okay, so I know that tangent is sine over cosine, but I need to do the cosine over the sine. So cosine is like your x and sine is like your y. So cosine means I'm going to go 1 to the right, so 1 to the right, and then I don't go up. Cosine is like your x. I don't go up, I don't go left or right, so 0, but I do go up 1. I go 1 to the left, but I don't go up. And here I know this is 1 and negative 1 because radical 2 over 2 divided by radical 2 over 2 is 1. And we have over here, we have a negative radical 2 over 2 divided by radical 2 over 2. So this helps me if I go just up a little bit. I can recreate this half circle. And 1 divided by 0, this is undefined. This is 1. This is 0. This is negative 1. And this is undefined. So this is for a basic cotangent, but we do have a value up front. So as I graph it, I need to keep in touch that I need to take 1/2 times these output values for the cotangent function. So let's start right here. It's undefined. So I'm going to make my dotted line going down. Then I move 1 step to the right. By the way, that's a distance of 1 pi over 12. And 1 times 1/2 is 1/2. Then I move another step, and 0 times 1/2 is 0. Negative 1 times 1/2 is negative 1/2, and then I'm back to undefined. And I'm going to continue that here to the left and moving back over here as well. Okay, and back down through, and back down through, down through, and down through. And we completed number 12. Let's take a look at number 13. Now, without going back and referring to this, so it starts with a C, that means I want to know what is going to be. I can't start with a C again, so I want to know sine. Without referring to this and looking at what it looks like, how can I quickly do that? I know sine and its reciprocal have a period length of 2 pi in the parent function. So I'm going to draw a quick circle, and then I'm going to identify all of the signs. This is how I would do it. Remember, you will have a unit circle. You can write whatever you want on the unit circle, and that will help you as you do this. So sign, that's like your y value, 0, 1, 0, and negative 1. The cosecant is reciprocal, so I'm going to do 1 over each of these. So I have an output here, 1 over 0, that's undefined. 1 over 1 is 1. 1 over 0 is undefined. 1 over negative 1 is negative 1. And back to undefined. So this is my starting step 1, step 2, step 3, and step 4. I've taken care of adjusting now what this looks like, but now I need to identify what's the period in the x scale. So sine and cosine and sine and cosecant and cosine and secant. I may be mixing up my words here. Sine and cosine and their reciprocals will all have a period length of 2 pi. So I'm going to take 2 pi, and since this is a reciprocal of sine, I'm going to divide it by the value in front of the x. So divided by pi over 2, which is like multiplying times its reciprocal, 2 over pi. I get 4 pi over pi, which is the same as 4. And dividing this by 4, I get an x scale, or a distance on the x-axis, of simply 1. I've taken care of this part. Now I need to multiply the output values by 2. So that does not affect when it's undefined. 1 times 2 is 2, another undefined. Negative 1 times 2 is negative 2. And I'm going to press pause here and continue to make these. Okay, so I'm making them here, and down here, up, down, up. Now, I did have students, when you attempted some try these problems, that wanted to connect these. These are going to go in the opposite direction here. I'll press pause. Do not just leave the dots. I do want to see this completed. Let's now look at number 14. All right, so when I think about sine, I have a unit circle here. So the sign here, like the y value, is 0, 1, 0, negative 1. Now, I do see something that's different than 11, 12, and 13. I see that we're going to reflect across the horizontal axis. The 1 over 4 is going to adjust the period and x scale, and I'm going to shift everything up 2. I should think of this as my new origin because I've shifted it up 2. Done with that. Let's now identify the period length and the x scale. So sine and its reciprocal are going to have a period length of 2 pi. So I'm going to take 2 pi and divide it by 1 over 4. And doing so, you multiply by the reciprocal to end up with 8 pi. So I have 8 pi as the period length. I divide that by 4 because there's 4 steps to end up with each step along here on the horizontal axis is a distance of 2 pi. Taking care of this. Now this negative sign is like a negative 1. So 0 times negative 1, it's still 0. But remember, here is my 0 because I've moved everything up. 1 times negative 1 is negative 1. So I've moved one step over and down 1. 0 times negative 1 is 0. And I just keep going around so we can see it's just like this. And back. So it's going to be a valley and then a hill, valley and then a hill, and I'll go in the opposite direction as well. Don't just leave dots. I do want to see it. And I've completed number 14. Now I'm going to give you some helpful test tips. Your helpful test tip is that on your upcoming exam, you will need to know how to graph all 6 of the trig functions. So don't just memorize sine, cosine, tangent. Make sure you know how to graph, just like this, how to graph the cosecant, secant, and cotangent. That's a helpful test tip. Also, you will have a couple problems that have a vertical shift of either going up, or if this was a negative 2, we'd have moved this horizontal line down too. A common mistake I also saw is that students forgot when they work with tangent and cotangent, the phase length of the parent function is only pi, not 2 pi, in identifying this. Let's move on now to part 3. Part 3 of the Unit 9 review. Let's start by recognizing what our formula is that you need to memorize. Also, remember that when we are expressing that interior angle, it needs to be in radians. So if it's not, we need to convert it. And that's the case for number 15. Number 15, I'm going to take 142 and I'm going to divide it. So this is in terms of degrees. I'm going to take it times pi over 180. So here we go. 142 divided by 180, put it back into a fraction, and I have 71 over 90. So I'm going to change this right away. This is equivalent to, I just can draw an arrow, to 71 pi over 90, over 90. I misread that. All right, so I know that my arc length is 4.6 centimeters. I don't know the radius, and I know the interior angle is 71 pi over 90. Now, how do I solve for the radius? I'm going to multiply by the reciprocal. 90 over 71 pi times 90 over 71 pi. Okay, here we go. 90 times 4.6 divided by 71 pi. Make sure to put parentheses around the 71 pi because it's not just 71, it's 71 times pi that we're dividing by. All right, and we get an answer of 1.856. So x equals 1.856. Now here's the key. Let me grab the previous one. So we get an answer of x equals 1.856 approximately. And now we need, this is in terms of centimeters, you've got to read the directions. This is your helpful hint for your test. You absolutely have a problem like this. And we're going to practice one more in this video than it's provided. So we're going to do 15, 16, and an additional one to give you that extra practice. We need to turn this into millimeters, and then we need to label it correctly. So to go from centimeters to millimeters, we need to multiply by 10. So 1.856, when you multiply by 10, you just move the decimal one place to the right. 18, you can see it's 18.56, 18.56, and that is in terms of millimeters. Let me create a new problem before. So this is additional problem, and I think this will help prepare for your test. Hint, hint. We want our final answer of this interior angle to be in terms of degrees, and we're provided with both a radius and an arc length, but they're not in the same units. Now we have a choice whether we want to convert both into centimeters or both into millimeters. It's your choice. I think it's easier to go from centimeters to millimeters because I just have to multiply by 10. So if I want to rewrite this, I can change 3 times 10 would be 30 millimeters. As long as these are the same, then I'm able to correctly achieve this angle. So I have this is equal to r theta, then my arc length is 74, my radius is 30, and I will divide here by 30. So 74 divided by 30, but this is in terms of radians, and we want to convert this into degrees. So I have 2.46 repeating. To change this into degrees, I'm going to multiply it times 180 over pi. So I'm going to go times this previous answer. That way I don't have to round it. Times, in parentheses, 180 divided by pi. And here's my answer. So this angle would be approximately 141.3 degrees. Okay, let's go back and do number 16 next. Okay, let's look at number 16. So number 16, just like the last problem, they're not in the same units. I know that each foot is 12 inches, so 12 and 12 gives me 24 inches. And we're going to do this just like that practice problem I went over. So our arc length equals radius times theta. We have 32 inches for the arc length. We have a radius of 24. I'm going to divide by 24. We want to go back into degrees afterwards. Make sure before you hand in your test that you reread how each question wants you to display the final answer. So 32 divided by 24, this is in terms of radians. Now we're going to multiply that by 180 divided by pi, keeping those both in parentheses, and we have approximately 76.4 degrees. This is the interior angle. Let's look at 17. Okay, I've cleared my calculator, and I'm going to take time in plugging this in. So first I'm going to come up to the front, going to y equals, and I'm going to type in -2 sine. Now, when I plug this in, it's very important that this portion goes into its own parentheses. So I'm going to hug the 2 pi divided by 3. And I'm going to put extra parentheses in here. So I have an extra hug, so 2 pi divided by 3. So this portion right here, and then I have a subtract 2. Now I want to end that. So 1, 2, 3 fronts, 1, 2, 3 backs, and now I subtract 1. Let's go to mode and make sure I'm in radians. It automatically, when you do second plus 712 and it clears your RAM, it automatically puts it back into radians if you're unaware of that. Let's also look at this so we can have a good view of what this looks like. And we can identify the period both here and we can identify it here. But how do I figure out the period length? I'm going to graph this in just a second. So I'm working with the sign, which I know I'm going to take 2 pi and divide by whatever is in front of the x. So I'm going to divide by 2/3. Well, that's the same as multiplying by the reciprocal of 3 over 2. So I get 6 pi over 2, which is the same as 3 pi when you reduce it. The amplitude, excuse me, it is not -2. This negative sign is separate than 2. It's like -1 times 2 sine of blah, 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 blah. Why is it a -1? -1 says that we're going to reflect it down. So instead of being a sign that goes hill and then valley, this says it will reflect across the horizontal axis. So it'll go down and then up next. So separate. Other people will tell you to figure out the amplitude, you're going to take just the absolute value of this. So always make this positive. So the amplitude is 2. It's going to be stretched by a factor of 2. So let's graph it. And then I do want to change this here. I'm going to, well, we should be able to figure out our answers actually even without that. So I was going to change, we can come here, by the way, and we can see our x scales. So if we wanted to make this even prettier, for instance, we could say, okay, I want to go -3 pi to the left, -3 pi to the right. But keep in mind, we are going to move this 2 to the right. And then I could see, I divide this by 4, I'd have an x scale of 3 pi divided by 4. And let's go, because there is a shift, let's go 4 up and 4 down. Okay, so we have a period length of 3 pi, but we're moving it 2 places to the right. So keep that in mind. So when I do 3 pi and I do a -3 pi, remember we've taken this whole thing and we've shifted it to the right. So I need to account for that by taking 3 pi and I'm going to add 2. And here I'm going to take 3 pi and I'm going to subtract 2. Let's take a look what this looks like. Oh, what did I do wrong? What did I do wrong? Minimum, maximum. That looks good. X scale. Oh, it's supposed to be negative. That's my part. The minimum was supposed to be 3 pi, subtract -3 pi. And I'm going to add 2 to that. And this is 3 pi. And I'm going to add 2 to that. Now, you don't have to make this. I'm just doing this so you can see it and it's in a pretty form. That's the only reason why I'm doing it. You're welcome to just graph this without. So we have moved it 2 places to the right. So if I can take a piece of paper and cover this up, I'm going to go 2. So watch. 1, 2. This is the start of our curve. This is the start of our curve. And then we can see that it's also been shifted down 1. So it's been shifted down 1, and we can see what the curve looks like. Okay, let's figure out what some of these answers are. So I'm going to go to 0. So I'm going to go second trace 0. Oops, sorry. Value of 0. And here's my answer. So I could plug in 0.818. Now I just want to go over this again. You didn't have to do all of this. So if you just had a normal graph that looked like this and you graphed it, so you didn't monkey with trying to adjust the window at all, I want to demonstrate how we could get the exact same answer. I'm going to plug in again second trace, plugging in 0. Oh, that's the exact same answer. Okay, second trace, and this time I'm going to plug in 3 pi divided by 2, and we get an answer of -2.818, it looks like. Now let's evaluate 3 places at this position. So let's go back here, get in hit trace, so second trace, and I have -1.9, oh, yep, 0.92, and we have an answer of -1.276. To not stress you out, remember, you didn't have to adjust this, we could get the exact same answers by just using the trace feature. Let's go on right now to the looking at number 18. This is very similar to one of the examples Mr. McFarland did in his instructional videos for lesson 5. We have a television camera at the ground level is filming the launch of a rocket ship from a 0.500 meters away. The height of the rocket ship can be expressed by this, so the height can be expressed. So I'm going to come up here to, and by the way, I see degrees. So right away, I'm going to change to degrees, and then I'm going to go to y equal and do the 500 times the tangent of this, and I'm going to look at the degrees, and I want to go out far enough. So let's go 0 to, maybe we can go 0 to 180. Zoom fit. Okay, so when I go to second trace and I'm plugging in degrees, it's going to give us the height. It's going to give us this height. If we know this degrees, then we know the height of the rocket. Here we go. Ready? Second trace. And I'm going to go value of 20. And we have 181. So 181.95. 181.8.95 or 99 if we rounded it. Let's go and type in 90. At 90, whoops, sorry, it was 50 was next, my fault. Well, 90, by the way, is going to be our next one. When you do not see an answer, it's going to be to infinity. Let's go to 50. 50 is going to be 595.88 if we round it. 0 is going to be 0. And now we're going to use the Pythagorean theorem. We know this distance is 500, and we've already figured out that 50 was 595.8768. So to figure out this length, when we're working with an angle of 50, I can do 500 squared plus 595.7868 squared. And remember, a squared plus b squared equals c squared. So I figured out what this is, but now I need to take the square root of this value. Square root of this value, and I have 777.86. Let's move on to number 19. All right, so I've started by plugging in for number 19. I plugged it in the provided function. First, I reset the calculator, making sure that, excuse me, recognizing the output values or the y functions will be in degrees. Excuse me, I'm tired. Now the window, we're talking about an entire year, so I went from 30 to 365, and then after doing that, I did zoom fit. All right, so this looks like the output. So this would be like our winter time. This would be our winter time, our summer highs, and then back to December, and this would be December 31st. So let's figure out July 4th. I'm going to go second trace value and type it in 185, and we get an answer of 65. And let's round that to 65. Looks like 65 degrees. Okay, now December 25th would be day 359 of the year, and we have a temperature of 26.7. By the way, maybe I should have rounded this to the nearest degree, 65.1. Okay, now let's go up here. What is the maximum average temperature over this year? Second trace maximum. So I'm going to go from 0. Whoops, second trace maximum, my fault. So we're going to go left bound. I'm going to do 0 all the way to 365. We can see that the average high here occurs at 25. Or is that 26? No, 25.4. 25. Oh, I forgot to push enter. There we go. There we go. 68. So the confusion there. Let me grab a Kleenex. Sorry, it looks like I'm coming down with the cold. Thank you for your patience. Second trace, I didn't press enter all the way through. So here's my left bound, here's my right bound. So from the beginning to the end of the cycle, and I forgot to press enter. That's why I started right 25. So 68 degrees is the maximum average temperature. On what day is the temperature the lowest? So let's find the minimum. So second trace, let's find this minimum. I'm going to do the same thing. 0 to 365. pressing enter, and I get on day 365. So this is the temperature, but it's on day 365. Well, day 365 is going to be December 31st. All right. That is going to be when the average is the key. Okay. Now, if they asked us what is the minimum, what is just the minimum? So this is the average. The key is average here. But if we want to just do the minimum here, that gets a little confusing too. We could have come over here. And so if you looked at his answer key, he had two answers because I don't think the question was worded well. And so if I'm a student or even going over this problem and I can see how the calculator produced this answer of 365, but that's because it's the average. Now, if I just want to find the direct minimum on what day does the lowest temperature occur on this cycle, we can see it is 32 days in, 32 days in. And so we would start with January 1st and we'd count an additional 32 days and we'd end up with February 2nd. So just know if this happens, this is the way I produce it. But if you gave me either one of these answers, I would count both of them correct because I don't think it's well worded. Average should produce this. Okay, let's go here. Determine the period. Well, the period is 1 year, so it's 365 days. Let's look at our last. Cleared the calculator, and I'm going to go to Stat, and I'm going to go to Edit. I'm going to put in sales, and I'm going to put in months. Let me do that for us. So if you are unaware of this, the time is always going to be your X time or your L1. So this is going to be confusing for you. Make sure time or months go into your L1, and then sales within thousands of dollars goes into your L2. All right, so I'm going to go Stat, Calculate. Sorry, my kids are really loud in the background playing a game. I'm going to go all the way down to Sign, pressing Enter all the way through. Okay, now I'm going to keep note that I see down here my B is equal to, I just want to write this down, 0.600606901. Okay, so this is what I have. Now I want to enter that in, but I don't want to type that all in. So if we go back up, if we go up to y equals, I can insert exactly what was on the screen by hitting vars, going down to stats, going to EQ, which is equation, and this will take that regression model and enter it in. Okay, now let's look what we need to do here. This is the key. Circle when we know the initial is. So initially when this is done, it's January of 2006. So I've gone through, I've done the model. I'm going to graph it here in just a second, but it goes past, so it goes out here to, well, it goes past even to 2007. So I think I'm going to do 24 months. So let's go to Windows and let's go 0 to 24 and go Zoom Fit. What does this look like over a 2-year period? I'm going to start drawing this. Okay, there, and here. Okay, so this is what it looks like. Now we need to predict. So this is going to be what? So from January 2006 to January 2007 is 12 months, plus we have 4 additional months. So let's find month 16. Second trace, remember that our X's are in terms of months, value of 16. Now be careful here. Don't write down 28. This is in terms of thousands. So I'm going to move that decimal 3 places to the right. 764. It's in terms of thousands of dollars. All right, now let's find the period for this. So a couple ways we could do it. We could measure from here to here. We see that's 1 cycle, right? We could measure from here to here. Let me get this out. There's a couple different ways that we can identify what this period is. So I'm going to show you. I wrote down when we did Stat and Calculate, I knew that the value in front of the X would be used when I identify what the period is. So I went all the way down here and entered through. And so the B value I wrote down. So in order to identify the period, I'm going to take 2 pi because it's a sine function. I'm going to divide by the value in front. So let's do that next. 2 pi divided by 0.600609001, and this gives us a period of 10.46. Now, if I was also able, I can see that this is, these are cycles. So if I also took from this minimum to this minimum, let's see if we get the exact same number. Second trace minimum. And so, oh, there's a minimum, so I'm going to go left bound, right bound, and back to that value. I'm going to write this down. So let me just find a random place to write this down. 11.748963. Okay, let's try the next one. Oops, sorry, second trace minimum. Let's find the next one. Whether I go to the left, right, it doesn't matter. Let's go back here to the left. Okay, so slightly to the left, slightly to the right, back to that spot, and I have an output of 1.2875681. Okay, let's subtract those. That's the distance between them, 11.748963. Subtract 1.287568, and we get the exact same answer. Helpful hint for this problem will be that when you take your exam next week, it will not be sales in months. It will be days and time. Days will be your X value, and the output of time will be your Y. Days and time.